Another example, the kind of the last one that we have to do, is the one where you have just coarse grain soil. So for example, if you have a profile where you have fees are, let's say, 30, 35, and 40 degrees. Okay, this is a poorly graded sand, well-graded gravel. Okay, you're going to support a load of 300 kilonewtons with a square foundation that is unembedded. Okay, let's say this is 1 meter, 0.5 meters, 1 meter, and let's say you have well-graded sand here also that has a 40 degrees fee, and this is like 10 meters or something like that. Okay, so basically the stratigraphy is all coarse grained. First thing you do, put the water table up here, because that's what you're going to use or assume for design. Now, in the short term, when you load this foundation or construct it and load it, etc., you're going to have drain conditions. There's not going to be any excess pore pressures because the soil is coarse. So in the short term, you have drain conditions. In the long term, of course, always there will be drain conditions. So the only condition that is relevant for this design is drained. You will never conduct on drain conditions for a coarse grain soil unless you are expecting an earthquake, and then you do a totally different type of analysis. Okay? But for bearing capacity, static, not dynamic, all you need to think about when you have coarse grain soil is drained conditions and the fee. There's no SU for coarse grain soil. It doesn't exist really. Okay? So, what do we do here? Well, the first layer is 1 meter thick, so what we can do is simply assume that we have a 1 meter foundation. So B equal 1 meter. Factor of safety, 1/2 times 1 times 10 times n gamma star. N gamma star for 30 degrees, because the influence zone is 1 meter deep, is 13.44. We have used this before, right? And the load is 300, or the applied stress, Q, is the load, 300, plus the weight of the foundation, which is 1 squared times 1/3 times 28, divided by 1 squared. So what do we have here? This is 5 times 13, right? Which is about, what, 70? And this is 28 over 3 is like 9, so 309, right? Clearly, this is less than 1. So that doesn't work. Less than 1, this is about 0.4 or something like that, right? So definitely way lower than what we want, which is 3. So let's choose something like 3.5 meters, just for the sake of doing a big weighted average there. Okay, so factor of safety is equal to 1/2 times 10, times 1/2 times 3.5, yeah, times 10, remember this is B, times gamma prime, times n gamma star. But n gamma star is a function of the influence zone, of course the fees within it. So if we have a foundation that has a B of 3.5, then we have 1 meter plus 0.5 plus 1, that's 2.5 plus 1. So we have 1 meter in this soil, 0.5 meters in this soil, 1 meter in this soil, and 1 meter in this soil, which is to say 2 meters in 40-degree soil. Even though the soils are different, 2 meters in 40-degree soil. So the average fee is 1 meter in 30-degree soil plus 0.5 meters in 35-degree soil plus 2 meters in 40-degree soil. I hope that's clear. Okay? All that divided by 4 meters of soil. 1 plus 0.5 plus 2. Okay, there's 2 meters here of 40-degree soil. That's why I grouped it. Even though it's different soil, you have the same value of fee. So this fee average ends up being 32 or 31.8, so 32 degrees. Sorry, I noticed I made a mistake here. You probably already noticed it. This is not 4. We assumed 3.5, right? So 1 plus 0.5 plus 2 is 3.5, not 4. So the average is 36.4 degrees. So the n gamma star, according to the chart here on your reader, the chart tells us that for 36.4, the value is about, it's between 34 and 40, which is about 37. Okay? And then we have 300 plus 3.5 squared times a third of 3.5 times 28 divided by 3.5 squared. And the factor safety is very high, 11.3 meters. So that's a huge square footing. In fact, something that big, or sorry, what am I talking about here? This is factor safety. Sorry about that. It's 3.5 by 3.5. So that footing is basically too large for this load, because the factor safety is, this footing is too large for this load and this soil. Notice that the load and the soil, of course, are in the equations for you to get the factor of safety. So too large, 1 meter by 1 meter was too small, 3.5 meters by 3.5 meters is too large. So clearly what you would do in this situation is you would then guess a lower B, maybe like 2 meters, and then proceed and hope that you will get 2.8 to 3.2, let's say, as the factor of safety. Okay, so here what I wanted to show you essentially was that first, when you have a coarse grain soils in the influence zone, in this case you will always have, because there's only coarse grain soils in the example, the only condition you care about is the drained one. There's no undrained condition that is relevant. And number two, I wanted to show you that just another example of how to get a weighted average. Even though I made a mistake here, I put 4. It's not 3.5 clearly, because we assumed 3.5 here. So 1, 2, 3.5. Okay.